Hello and welcome to 101 Computational Problems with myself, Glenn Gilchrist. These problems are taken from my upcoming book, 101 Computational Problems. So today we're going to have a look at the first problem in the book, which is lovingly called Fuzzball. And we can read there what the challenge is. So Fuzzball. And I'll read it out. In a game of Fuzzball, an end consists of 11 throws of a ball by a visioner and a stander. The stander aims to hit the ball towards the target. Each group of 11 throws is called a sub. You need to create a function that converts the total amount of throws into the format of subs.balls. And there are some examples given that 5 throws is 0.5, which isn't a half, it's 0 subs with 5 balls left over. 12 throws is 1 sub with 1 ball left over. And likewise, 21 throws is still 1 sub, but this time there are 10 left over. So we're going to think about how we can start to deconstruct this problem and code. In this case, I'm going to code something up in Python using JupyterLabs. So first thing, I'm just going to start with a comment really, so I know what this program is going to do for me. So I'm using Anaconda and JupyterLabs because it's interactive, because it's going to allow me to implement some of the code as I go along to see what happens. So each group of 11 throws is called a sub. So I'm counting in 11s, is that right? Yeah, so 12 throws is 1 sub and 1 ball. So one thing I could think about, I suppose, is if I just print out let's just say we've got 12 throws and I'm dividing that by 11. So we're calculating 12 divided by 11. And I know the answer to that is going to be 1 and something, 1 and some kind of remainder. So just for the case of making this computational, let's make a variable and we'll say x equals 12 in this case. And we're going to change the print statement to have x in there, just so that I can keep on changing the variable. If I rerun the code, it'll give me the same answer. So what I want is if that now says, let's say it's 13, and I run the code, 13 divided by 11 is still going to be 1 point something. The point here is it's 1 sub, to use the words we've got here, it's 1 sub with some balls left over. So the function in Python int, if I wrap that calculation with the int, what will happen is it will just return rounds everything down, it will just return the integer value. So in this case, it will return 1 with nothing after the decimal place. So that's a bit closer to a solution, because if I now say, let's say I say 21, okay? So if I now make x equals to 21 and run the code, I still get 1 as the answer, which is the first part of the number. What I now need to find is the remainder of what's going on here. So I need to think a little bit more about, can we be a bit clever in how we're doing it? So I've got x is 21 and I've got the calculation in the print statement. So if I make another variable y, which is this x divided by 11, okay, and inside the print statement, if I just print y this time, check it works, I get the same answer, so we're fine. So I've got x is 21, y is this integer value of x divided by 11. But now I need to do some kind of calculation. So if I type in 21, which is 21, one lot of 11 is 11, but I've got 10 left over. So I need to start calculating this remainder value. So the first thing I'm going to do is I'm going to create a new variable, which is going to be 11 times y. So when, in this case, y ends up being 1, because I've got one lot of 11, and I need to calculate the remainder, so I'm going to create another variable, which is the x value that we start with, take away this I value, because the remainder is going to be what's left over. So this time if I print y comma the remainder, I'm anticipating I get 1.10 for 21. Do I get 1.10? Well, I get 1 and a 10. So does that work for the other examples? If I say x is 12, I would be anticipating a 1 and a 1, which I do. If I type 5 throws, so x is 5, do I get the right answer? I get a 0 and a 5. So I've got the values out, but it's not quite formatted correctly. Okay, so now I can create yet another variable. This time I'm going to call it FB for Fuzzball, and it's going to be a string. And I'm going to take the string value of y, just wrap the integer, just wrap the number in a string, and I'm going to add a decimal point, and I'm going to add the string value of rem. And this time I'm going to print out just FB. So I'm anticipating this should say string value of y is 0, point, and the rem is 5. So when I run this code, I should get 0.5. 0.5, which I do. If I go back now to 12, I should get 1.1, which I do. And if I go to 21, I should get 1.10, which I do. So my code works, but it's still not quite right because it's still not really a function. It's just me testing it. So I'm going to go right to the back here now, and I'm going to define def a function, and I'm going to call it Fuzzball. And into Fuzzball, we're going to pass x. We're going to pass a variable, a number, colon on the end. And the function is actually going to be pretty much everything that we've already done, except I'm not hard coding x, so I'm going to get rid of that. But all of the other values fit under the function. So I've calculated FB. To get FB out of the function, I'm going to return FB. So now if it won't work, I've got to create Fuzzball. So into the print statement, I'm going to pass Fuzzball, and I'm going to load a value into x. So let's say Fuzzball of 21. So what this will do is into Fuzzball, it will push 21. So up here, it'll push 21 in here, which is x, and it'll go through all the calculations that we previously did. So print Fuzzball 21 should produce 1.10 as the answer, which it does. If I change print Fuzzball to 12, we're saying it should be 1.1 as the answer, which it does. So I think we've met the solution, but there's something else we can do over a little bit further, which is around that print statement. If I make another for statement, if I give it a range of values for a in range 10, let's say. So a in range 10 will start at 0, and it will count up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which will give us 10 values. And into Fuzzball, if I pass a, what will happen is it will print the Fuzzball of a, but let's also print the value of a. So if I do a comma Fuzzball of a, what I should get is 0 and the Fuzzball of 0, 1 and the Fuzzball of 1, and so on. If I run the code, it's exactly what I get. I get 0, Fuzzball of 0, 1, Fuzzball of 1. Now that's not particularly interesting because they're the same values, aren't they? Because this is dividing by 11. It only starts to do anything interesting once Fuzzball gets beyond 11 or beyond 10. So if I go Fuzzball up to 20 and rerun the code, I get 0 of 0, 1 of 0.1, so on, so on, so on, so on. When I get to 10, I get 10 and 0.10. And then when I get to 11, I get 1 sub and no bulls. which was exactly as the function was required. And then 12 is 1 sub and 1 ball. 13, 1 sub and 2 balls, and so on. So through an interactive process, we've taken a problem over here with, this is Deleth the duck. We've taken a problem with Deleth the duck, and we've calculated a function called Fuzzball. We created a function Fuzzball, and we've tested it interactively to meet the solution, or to create the solution for this problem. So that was the first in 101 computational problems. In this case, I've used Python, but as we move on, I will use other languages. I'm even going to use a bit of BASIC and some older languages, because it's the problem-solving computational aspect of it, not necessarily just doing this in Python. So I've been Glenn Gilchrist. Thanks for listening. Remember to like and subscribe. Thanks a lot. Bye-bye.